The story of human innovation begins with a civilization that defied time itself. The Roman Empire stands as a testament to human ingenuity, a remarkable civilization that transformed engineering from a mere practical discipline into an art form that would reshape the very foundations of human progress. Picture a world where technological marvels emerge not from silicon and microchips, but from stone, water, and human imagination. The Romans were more than conquerors. They were visionary architects of civilization whose engineering prowess would echo through millennia. Their empire stretched across an unprecedented expanse, spanning from the misty landscapes of Britain to the sun-drenched territories of the Middle East, connecting diverse cultures through unprecedented technological achievements. What set the Romans apart was not merely their military might, but their revolutionary approach to solving complex challenges. They were master problem solvers who viewed engineering as a sophisticated language of progress. Their innovations weren't just structures. They were living, breathing systems that transformed how societies functioned, communicated, and understood the potential of human creativity. For over 1,000 years, Roman engineers pushed the boundaries of what was possible. They didn't just build, they reimagined entire systems of urban living, transportation, water management, and architectural design. Their works were so advanced that many of their technological solutions remained unmatched for centuries after their civilization's decline. Imagine aqueducts that defied gravity, roads that connected continents, and architectural techniques that would become the blueprint for future civilizations. The Romans understood something profound. True engineering is about more than constructing physical objects. It's about creating interconnected systems that elevate human potential, solve complex problems, and connect communities across vast distances. As we embark on this journey through Roman engineering, prepare to be transported to an era of unprecedented innovation. We'll explore how these ancient masters transformed raw materials into sophisticated technologies that continue to inspire engineers and architects to this day. Get ready to discover a world where human creativity knew no bounds, and where every stone, every arch, and every carefully designed system told a story of remarkable human achievement. Are you prepared to dive into this fascinating exploration of Roman engineering? Get ready to challenge everything you thought you knew about ancient technological capabilities. Like and subscribe to Legacy of Empires to join us on this extraordinary journey through the annals of human innovation. Archaeological evidence reveals the Romans as unparalleled masters of systematic engineering, transforming landscape and infrastructure through breathtaking technological innovations. Their archaeological remnants are not mere historical artifacts, but sophisticated technological blueprints that continue to astonish modern experts. The aqueducts stand as perhaps the most remarkable testament to Roman engineering prowess. These extraordinary water transportation systems represented far more than simple conduits. They were complex hydraulic networks that embodied mathematical precision and scientific understanding generations ahead of their time. Spanning hundreds of kilometers across challenging terrain, these structures transported millions of liters of water daily using nothing more than gravitational principles and meticulous mathematical calculations. Consider the extraordinary technical challenges these engineers confronted. They navigated mountainous landscapes, calculated microscopic elevation gradients, and designed structures that maintained water flow with remarkable consistency. Roman surveyors and engineers used sophisticated measuring tools like groma, a vertical staff with horizontal crosspieces, to ensure perfect alignment across vast distances. Their understanding of hydrostatic pressure and terrain topography allowed them to create water distribution systems that many modern cities would envy. The road networks complemented these water systems, representing another pinnacle of archaeological innovation. Roman roads were not merely pathways, but integrated transportation infrastructures engineered with extraordinary sophistication. Constructed in multiple layers, typically consisting of compressed gravel, stone, and carefully fitted surface rocks. These roads were designed for durability, drainage, and efficient movement of people and goods. Archaeological excavations have revealed road construction techniques that demonstrate remarkable engineering intelligence. These roads featured crowned surfaces for water drainage, solid foundations that could support heavy traffic, and maintained consistent gradients to facilitate easier travel. Many of these roads remain partially intact today, a testament to their exceptional construction quality. The archaeological evidence suggests that Roman engineering was fundamentally systemic. They did not simply build isolated structures, but created interconnected networks that transformed urban and rural landscapes. Their approach integrated architectural design, mathematical precision, material science, and a profound understanding of natural principles. Water management systems exemplified this holistic approach. Beyond aqueducts, Romans developed sophisticated underground sewage systems, public bathhouses with complex heating mechanisms and irrigation technologies that transformed agricultural possibilities. The famous Cloaca Maxima in Rome, one of the world's earliest sewage systems, demonstrates their advanced urban planning capabilities. Each archaeological site tells a story of human innovation, revealing a civilization that viewed engineering as an art form, a scientific discipline, and a means of expressing cultural sophistication. The Romans did not just construct, they reimagined the relationship between human societies and their constructed environments. By combining mathematical brilliance, material expertise, and a visionary approach to problem-solving, Roman engineers created systems that would influence technological development for centuries to come. Their archaeological remnants are not merely historical curiosities, but living testimonies to human potential for innovation and systemic thinking. Vitruvius emerges as the quintessential Renaissance man of the ancient world, a polymath whose intellectual contributions transcended the boundaries of traditional architecture and engineering. As the most celebrated architectural theorist of the Roman era, he personified the sophistication of Roman intellectual achievement. His seminal work, De Architectura, a 10-volume treatise, became the foundational text that would influence architectural and engineering thinking for centuries, serving as a primary source of knowledge during the Renaissance and beyond. Beyond Vitruvius, Roman engineering was propelled by a remarkable cadre of innovative minds who approached technical challenges with scientific rigor. Apollodorus of Damascus stands out as another pivotal figure, an extraordinary architect and engineer responsible for some of Emperor Trajan's most ambitious projects. He designed the iconic Trajan's Bridge over the Danube, at the time the longest arch bridge in the world, and played a crucial role in developing advanced siege engines and architectural marvels throughout the Roman Empire. The Roman military engineering corps, led by highly skilled officers called praefecti fabrum, represented another critical source of technological innovation. These engineers were responsible for designing and constructing infrastructure during military campaigns, developing sophisticated siege technologies, building temporary and permanent bridges, and creating complex fortification systems. Their work was not merely practical, but represented a sophisticated integration of mathematical knowledge, material science, and strategic thinking. Marcus Vitruvius Pollio, commonly known simply as Vitruvius, epitomized the Roman engineer's comprehensive approach. He was not just an architect, but a holistic thinker who understood engineering as an interconnected discipline. His writings reveal deep insights into architecture, mechanics, hydraulics, and urban planning. He emphasized that true engineering requires not just technical skill, but a profound understanding of mathematics, astronomy, history, and philosophy. Vitruvius articulated principles that would become fundamental to Western architectural thought. He discussed proportionality, symmetry, and the importance of functional design decades before these concepts became mainstream. His work covered an astonishing range of topics, from city planning and building materials to water engineering and mechanical innovations. The Roman approach to engineering was fundamentally collaborative, with knowledge passed through apprenticeship systems and professional networks. Engineers were not isolated inventors, but part of a sophisticated intellectual ecosystem that valued practical innovation and systematic problem-solving. Archaeological and historical evidence suggests that these engineers were highly respected professionals. They were not mere laborers, but intellectual elites who combined practical skills with theoretical knowledge. Their training involved rigorous mathematical education, practical experience, and exposure to diverse engineering challenges across the vast Roman territories. Roman engineers understood that true innovation emerged from interdisciplinary thinking. They integrated knowledge from geometry, physics, material science, and cultural practices to create solutions that were both functionally superior and aesthetically remarkable. Their work represented a holistic approach to technological development that viewed engineering as a comprehensive art form. These visionary minds transformed engineering from a purely practical discipline into a sophisticated intellectual pursuit. They created not just structures, but entire systems of urban living that would influence technological development for millennia. Their legacy demonstrates that innovation is not about individual genius, but about creating integrated systemic solutions that elevate human potential. The Roman road system, known as via, represented far more than simple transportation routes. These were sophisticated communication networks that functioned as the circulatory system of an unprecedented continental empire, connecting diverse territories, cultures, and economies with remarkable engineering precision. Roman road construction was a marvel of advanced civil engineering, characterized by multi-layered construction techniques that ensured unprecedented durability. Typical road structures consisted of multiple strategic layers: a foundation of dense, compacted earth, followed by a layer of larger stones, then smaller gravel, and finally a precisely fitted surface of large, interlocking stones. This sophisticated layering created roads with exceptional load-bearing capacity and remarkable resistance to environmental degradation. The engineering principles behind these roads went far beyond simple path creation. Roman engineers incorporated complex drainage systems, carefully calculating road gradients to ensure water runoff and prevent structural damage. The roads featured slightly crowned surfaces that allowed rainwater to flow to the sides, preventing erosion and maintaining structural integrity. This sophisticated hydrology management was centuries ahead of contemporary road-building practices. Strategic considerations were equally important in road design. These networks were not merely transportation routes, but critical military and administrative infrastructure. They facilitated rapid troop movements, enabled efficient communication across vast territories, and supported complex trade networks. The famous saying, "All roads lead to Rome," wasn't just a metaphor, but a testament to the empire's extraordinary logistical capabilities. The road system's technical specifications were remarkably standardized. Most major roads were approximately 4 to 6 meters wide, allowing simultaneous passage of multiple carts or military formations. The famous Appian Way, constructed around 312 BCE, exemplified these engineering standards, spanning nearly 600 kilometers and incorporating sophisticated stone-laying techniques that would preserve the road for millennia. Archaeological evidence demonstrates the extraordinary longevity of these engineering marvels. Significant portions of Roman roads remain intact today, 2,000 years after their initial construction. The Via Appia, stretching from Rome to Brindisi, contains sections that modern vehicles can still traverse, a remarkable testament to Roman engineering excellence. Beyond physical construction, these roads represented a profound technological and cultural achievement. They weren't just pathways, but symbols of Roman administrative and technological sophistication. They facilitated not just movement, but cultural exchange, supporting the transmission of ideas, technologies, and social practices across an unprecedented geographical expanse. The road networks integrated advanced surveying techniques, mathematical precision, and a comprehensive understanding of terrain management. Roman surveyors used sophisticated tools like the groma, a vertical staff with horizontal crosspieces, to ensure perfect alignment across challenging landscapes, demonstrating an extraordinary combination of practical engineering and theoretical knowledge. Roman roads transformed transportation from a challenge of physical movement to a systematic, engineered solution. They represented more than infrastructure. They were living manifestations of Roman technological philosophy, integrated, purposeful, and designed to transcend immediate practical needs and create lasting societal transformation. Pause for a moment and reflect, which of these Roman innovations surprised you the most? Share your opinion in the comments. And if you're enjoying this trip back in time, don't forget to leave a like to support the channel. Roman engineering transcended mere construction, representing a profound philosophical approach to civilization itself. Their technological innovations were not isolated achievements, but integrated systems that fundamentally transformed urban living, social structures, and human potential. Water management exemplified this holistic approach. Aqueducts were far more than water transportation systems. They were complex social technologies that redefined urban possibilities. By providing consistent, clean water supplies, these systems enabled unprecedented levels of public hygiene, agricultural development, and urban population density. The cultural significance of these engineering achievements cannot be overstated. Roman aqueducts and water distribution networks represented a sophisticated understanding of public health centuries before modern medical knowledge. They created conditions for improved sanitation, reduced disease transmission, and supported more complex social organizations. Public bathhouses, powered by these advanced water systems, became critical social institutions. These were not simply cleaning facilities, but complex cultural spaces where social interactions, business negotiations, and community life flourished. The engineering behind these structures demonstrated an integrated approach to urban design that considered social dynamics alongside technical requirements. Agricultural transformation was another critical dimension of Roman technical innovations. Sophisticated irrigation systems developed through advanced hydraulic engineering dramatically expanded agricultural productivity. These systems allowed cultivation in previously challenging terrains, supporting population growth and economic expansion across diverse geographical regions. Urban planning reflected this systemic thinking. Roman cities were not randomly constructed, but carefully designed environments that integrated water management, waste disposal, transportation networks, and social infrastructure. Each technological solution considered multiple interconnected factors: structural integrity, environmental conditions, social needs, and long-term sustainability. The hypocaust, an early form of central heating, further illustrates their technical sophistication. This underfloor heating system, used in public baths and wealthy homes, demonstrated advanced thermodynamic understanding. It represented more than a comfort technology. It was a complex engineering solution that improved living conditions and reflected social stratification. Roman engineers understood that true technological innovation must serve broader societal objectives. Their approach viewed engineering as a transformative cultural practice, a means of expanding human potential, connecting communities, and creating more advanced collective living environments. This perspective fundamentally distinguished Roman engineering from merely functional construction. They saw technology as a dynamic, evolving language for solving complex human challenges, creating systems that would inspire technological thinking for millennia to come. Their legacy teaches a profound lesson. Genuine engineering transcends technical specifications. It represents a holistic approach to understanding and improving human collective experience, where every technological solution is an opportunity to reimagine societal possibilities. Roman technological innovations represented a quantum leap in human engineering capabilities, establishing foundational principles that would influence global construction and design for centuries. Their contributions extended far beyond individual structures, fundamentally reshaping how civilizations conceptualized technological problem-solving. Concrete stands as perhaps their most revolutionary contribution. Unlike previous building materials, Roman concrete, a mixture of volcanic ash, lime, and aggregate, possessed extraordinary durability and versatility. This innovative material allowed construction of structures that could withstand complex environmental challenges, enabling unprecedented architectural possibilities. The Pantheon in Rome, with its massive unreinforced concrete dome, remains a testament to their material engineering genius, still standing after nearly 2 millennia. Arch and vault technologies represented another critical engineering breakthrough. These structural techniques dramatically expanded architectural possibilities, distributing weight more efficiently and allowing construction of larger, more complex spaces. The Romans transformed these from mere architectural elements into sophisticated engineering solutions that could support massive infrastructure projects, from aqueducts to monumental public buildings. The hypocaust heating system demonstrated their advanced thermodynamic understanding. This underfloor heating technology represented a sophisticated approach to environmental control, circulating heated air beneath floors and within wall cavities. It was not just a comfort technology, but a complex engineering solution that reflected deep scientific comprehension of heat transfer principles. Bridge engineering further exemplified their technological sophistication. Roman bridges incorporated advanced mathematical calculations, using precisely engineered stone arches that could span increasingly larger distances. Many of these structures remain functional today, showcasing engineering principles that would influence bridge design for centuries. Their road networks established global standards for infrastructure development. These were not simply pathways, but integrated transportation systems, incorporating advanced drainage, multi-layered construction techniques, and strategic planning. The famous Roman roads connected distant territories, facilitating trade, military movements, and cultural exchange across unprecedented distances. Water management systems represented perhaps their most comprehensive technological achievement. Aqueducts were not merely water transportation networks, but complex hydraulic systems that demonstrated advanced understanding of gravitational principles, terrain management, and urban infrastructure design. The legacy of Roman engineering extends far beyond physical structures. They established a holistic approach to technological innovation, viewing engineering as an integrated discipline that combines mathematical precision, material science, and comprehensive problem-solving strategies. Their technological philosophy emphasized systems thinking, understanding that true innovation emerges from interconnected solutions rather than isolated achievements. This approach would influence technological development across multiple disciplines, from architecture and civil engineering to urban planning and infrastructure design. Contemporary engineers and architects continue to study Roman technological solutions, recognizing them not as historical curiosities, but as sophisticated engineering principles that remain relevant in modern design challenges. Their legacy demonstrates that genuine technological innovation transcends immediate practical needs, creating solutions that can transform human collective potential. Roman engineering represents a pivotal moment in human technological evolution, transcending the mere act of construction to become a sophisticated philosophy of problem-solving and societal transformation. Their approach to technology was fundamentally holistic, viewing engineering not as a technical discipline, but as a comprehensive method of understanding and improving human collective experience. What distinguished Roman engineers was their ability to see beyond immediate challenges, creating systems that would serve generations. They understood that true innovation is not about individual structures, but about developing integrated solutions that connect people, solve complex societal problems, and expand human potential. Their technological legacy teaches us profound lessons about innovation. Roman engineers demonstrated that meaningful progress emerges from systemic thinking that considers multiple interconnected factors, a deep understanding of natural principles, the ability to create scalable, adaptable solutions, viewing technology as a means of social and cultural advancement. These ancient innovators showed that engineering is fundamentally about human connection. Their roads did more than facilitate movement, they connected diverse cultures. Their aqueducts did more than transport water, they created conditions for complex urban societies to flourish. The Roman approach challenges our contemporary understanding of technological innovation. They viewed engineering as an art form, a scientific discipline, and a method of societal transformation. Their solutions were not just technically sophisticated, but deeply humanistic, designed to improve collective human experience. As we face increasingly complex global challenges, the Roman engineering philosophy remains profoundly relevant. They remind us that true innovation is not about technological complexity, but about creating systems that solve fundamental human needs, connect communities, and expand our collective potential. Their legacy invites us to reimagine technology not as a series of isolated solutions, but as a comprehensive approach to understanding and improving human potential. In their extraordinary achievements, we find a timeless blueprint for innovation that transcends technological boundaries. And so, we come to the end of another incredible journey through ancient history. If you enjoyed this trip through time, be sure to like this video, share this video with friends who also love history, and comment on what your favorite part was. And to make sure you don't miss our future explorations into the past, be sure to subscribe to the Legacy of Empires channel and turn on notifications.